Hello everyone. In this video, we will do the continuous version of the endowment insurance and the preferred insurance. Let's start with an end-year endowment continuous insurance, a benefit of one issued on an individual at age X. The insurer pays one at the moment of death as death benefit if the individual dies within the end-year period. If the person survives by the end of the end-year period, a survival benefit of one is paid at the end of the end-year period, whichever occurs first. Let Z be the present value random variable for this insurance. That is, if the individual dies at age X plus T, where T is between 0 and N, a death benefit of 1 is payable at this time point. The corresponding present value is e to the power minus delta T. If the individual survives by the end of the end-year period, a survival benefit of 1 is payable at age X plus N. The present value is e to the power minus delta times N. And we have the PMF of Z. If Tx is less than or equals N, the present value depends on Tx. And if Tx is greater than N, Z is a constant, e to the power minus delta N. The expected value. The end-year endowment insurance can be expressed as the end-year term insurance plus the end-year pure endowment. For the pure endowment, we never write a bar above the A because the survival benefit is never paid at the moment of death. So we have this expression. The actuarial notation, we have A bar and then X colon angle N. Expressed as integrals, the end-year term insurance, we have this expression. And then for the pure endowment, we have this expression, T equals N to infinity. And then the present value, e to the power minus delta N, and then times FTX, which is TBX mu X plus T. For this second integral, we can factor out e to the power minus delta N. And then the remaining part, the integral T equals N to infinity, TPX mu X plus T dt is simply NPX. And therefore, the second term can be rewritten as e to the power minus delta N times NPX. The second moment, with a pre-superscript 2, and then the big A bar notation. Similar relationship with the second moment. The second moment for the end-year term insurance, we have the first integral, and then plus the second moment of the pure endowment, which can be evaluated as e to the power minus 2 delta N times NPX. And then we can get the variance. For the end-year endowment insurance, we can rewrite this as the PMF of an end-year term insurance plus the end-year pure endowment. To get the variance, we can get it from the variance of Z1 plus Z2, where Z1 is the end, corresponds to the end-year term insurance, and Z2 corresponds to the end-year pure endowment. The variance of Z1 plus Z2, we get the variance of Z1 plus the variance of Z2, and then plus the covariance term, 2 times the covariance of Z1 and Z2. The covariance is the expectation of Z1, Z2 minus the expected value of Z1 times the expected value of Z2. Z1 and Z2 are mutually exclusive. So C1 times Z2 here is 0. And then we can get the covariance term in terms of the big A notations. And we can rewrite the variance of Z in terms of the various big A notations. And then let's move on to the N-year deferred insurance. The insurer pays 1 at the moment of death if the individual dies only after age X plus N. Let Z be the present value random variable for this insurance. If the individual dies within the N-year deferred period, the insurer pays nothing. And after that, a death benefit of 1 payable at the moment of death. The notation, we have N bar and then AX with a bar above the A. And we have the PMF of Z. Tx less than N, no benefit, so Z is 0. After that, the present value is e to the power minus delta times Tx. And we can get the expression for the expected value of Z, T from N to infinity. And then the corresponding second moment. From that, we can get the variance. All right, let's take a look at some relationship. The relationship for continuous insurance is very similar to the relationship for the discrete insurance. For example, the N-year endowment insurance, the discrete case. And then for the continuous version, we have this. Just simply include the bar corresponds to the endowment insurance and the N-year term insurance. There's no bar for the notation of the pure endowment. This applies to the second moment as well. And then the relationship for the whole life insurance on X, this equals to the sum of the N-year term insurance on X plus the N-year deferred insurance on X. The continuous version. And then for the deferred insurance, N bar AX, this is equals to the actuarial present value factor nu N times NPX, and then times a whole life insurance issue on age X plus N. And then the continuous version, the version for the continuous insurance, we have this. All right, that's it for today's video. Thank you for watching and see you in the next video.